Hey guys, let's go ahead and get started, and we're going to talk about two things today: the purpose of each subatomic particle in an atom, and we're also going to talk about isotopes. Now, the first subatomic particle we're going to discuss is a proton. Protons identify the atom. We've already talked about that each element has a unique number of atoms, so depending on how many protons you have tells us what type of atom you have, whether it's calcium or oxygen, or hydrogen or nitrogen. Now, neutrons provide stability for the atom. If I have too few neutrons, or if I have too many neutrons, the atom's going to be unstable. And we're going to discuss what happens with unstable atoms when we get to nuclear radiation. But neutrons provide the stability, and they need to have the right number to be stable. Electrons determine the chemical properties of an atom. So depending on how many electrons you have determines what type of properties you have. And chemical properties, remember, are kind of like characteristics. And so if we were talking about me, I could say I have light skin. Some characteristics of me: I have light skin, I have light hair, I have blue eyes, I have 2 arms, I have 2 legs. And so those are properties of Angela Swilly. So depending on how many electrons an atom has determines the chemical properties, like how flammable it is, how reactive it is, and those type of things. Now let's talk about isotopes. Isotopes are atoms of the same element, so that means they have the same number of protons. If they're the same element, they have the same number of protons, but they have different numbers of neutrons. So you need to know that isotopes are atoms that have the same number of protons but different number of neutrons. Let me show you an example. Here is hydrogen. Hydrogen 1, hydrogen 2, hydrogen 3. Those 1, 2, and 3 are the mass of that hydrogen. So you know how on the periodic table you look and in the very bottom number underneath the element symbol is the mass? This 1, 2, and 3 tells you the mass of this hydrogen, these hydrogens. So let's look at hydrogen 1. Hydrogen 1 has 1 proton in the middle and 1 electron orbiting on the outside. Hydrogen 2 has 1 proton, 1 neutron, 1 electron. Hydrogen 3 has a proton, 2 neutrons, and electrons. So the only thing changing in these isotopes are the numbers of neutrons. And as you can see, as you add neutrons, your mass increases from 1 to 3. Now, hydrogen 1 is the most common of these isotopes that are found in the universe. So that's why you see it on the periodic table, because the most common isotope is placed on the periodic table. But the masses of all of the isotopes are averaged together. So you take the 1, 2, and 3 and you average them together, but not just a normal average. You have to average them according to how likely they're found in the universe. But that's why your masses are a decimal point instead of having a whole rounded number. It's because they're an average. Now, this average of masses is called the average atomic mass. And the unit for that is U. Now, we've already talked about that the number at the bottom of the box underneath the element symbol is called mass number. And it is the mass number. It can also be called the average atomic mass. So it's just 2 different names that it can be called, and the average atomic mass has a unit of U. Now, the average atomic mass equals the mass number, and that also equals the mass, which we would give in grams. And so let's go ahead and talk about an example and what this means, how they all equal. Okay, this is what carbon looks like on your periodic table. And so down here, we've already talked about that this number at the very bottom is called the mass number. Well, this number is also the average atomic mass and just mass. Okay? So it's all 3. All 3 of these are just one number. So if I wanted the mass of carbon, I'm going to say that the mass of carbon equals 12 grams if I round it. The mass number is going to equal 12 because it's just a number. It's just the mass number, so there's no units after it. And then if I'm wanting average atomic mass, I put 12U. Because remember the symbol is, or I mean the units for average atomic mass is U. So it's the same number for every single one. They just have different units, and the mass number doesn't have a unit. Let's practice with another one and make sure we understand. Let's look at nitrogen, and let's make sure you understand what we're talking about. So what is the mass of nitrogen, what's the average atomic mass, and what's the mass number? I want you to pause the tape very quickly and jot these down what you think. All right, let's look at the answers. For the mass of nitrogen, we have 14 grams. For the average atomic mass, we have 14U. And for the mass number, we have 14. So it's the same number, they just have different units. Okay, let's look at some examples and see if you can determine if these elements are isotopes or if they're just completely different elements. And after we read each one, you can just pause the video until you have your answer and then restart it to make sure you're right. Element D has 6 protons and 7 neutrons. Element F has 7 protons and 7 neutrons. Are these isotopes or are these different elements? Go ahead and pause the videos and decide. They're different elements. And the reason is because element D has 6 protons, element F has 7 protons. They have different numbers of protons. That means they are different elements. Go ahead and pause the video and determine your answer for this one. These are isotopes, and the reason why is they have the same number of protons, but they have different number of neutrons. Read this, pause the video, and determine your answer. These are different elements because they have different number of protons. The neutrons don't even matter at this point because if the protons are different, it's always going to be a different element. Pause the video and determine if element Q or an element R are isotopes or different elements. They're isotopes because they have the same number of protons, different number of neutrons. Now we get a little tricky. We've already talked about atomic number and atomic mass, so now let's determine, are these isotopes or are they different elements? Pause the video and make your decision. These are isotopes because remember the atomic number tells you number of protons, and the atomic number are equal in both of these. So that means, or they're the same in both of these, so that means they're isotopes. Look at these and determine if they're isotopes or different elements. Go ahead and pause the video. These are isotopes also because the atomic number of element P is 92 and then element S has 92 protons. And remember, the atomic number tells us how many protons an element has. So that means they're isotopes. And they also have a different number of neutrons because if you take the atomic mass and say 238 minus 92, you realize that element P does not have 97 neutrons. So that means they have the same protons, different neutrons. All right, that was our last practice problem. Please write all of your questions on the left-hand side of your notes and make sure you come to class prepared to ask them if you need any help with anything. Have a great evening.